All right, we're ready to jump into understanding how computers are systems. They're made up of components that work together to do stuff that's interesting and useful. We're looking at the inside of an IBM PC. It's about 15 years old. Now, computers have become smaller and sleeker and faster, but the core components have remained the same. And so our process is going to be to understand the general function of these components. I'll show you some of the inside so you can see the components themselves. As I go through this, you should be assembling perhaps note cards or even just sheets of square paper that you've cut up, and we're going to represent each component of the computer with a note card. That will allow you to actually arrange these cards and connect them mentally and on paper to see that components individually have characteristics and names and qualities, and they connect up with other components. So as I go through it, be sure to have your note cards ready. You can use the Wikipedia page that's on computer hardware that's linked on a weekly guide in order to come up with some more specific definitions that I may not cover in this specific video. So let's get to it. Let's think about a basic task that you might accomplish on a computer. For example, playing a song. In order to get that to work, we have basic components, which is, for playing a song, we need some way for you to control which song you want to play. Now, let's imagine that we have a list of songs in a playlist, and we can use a keyboard and the arrow keys on the keyboard to select which song we want to play. So we have an up and down arrow. We have an enter key, and that has to flow into the computer. So we're going to figure out what might happen if you tap up and down to get to the song you want to play, you hit enter, and you expect the computer to figure out how to play it and ship sound out of the speakers. So at the other end of our system, we have speakers. And we want sound to come out of those speakers. So what is it that has to happen between the keyboard and the speakers for that to occur? We're going to draw ourselves a pretty large box that represents the case of the computer, meaning these are outside. Speakers and keyboard are outside of the case, at least on a desktop computer. Speakers, and we have the computer case. Let's take a peek at what goes on inside. We all have a sense that there is some sort of processor inside a computer. We probably know that these are called central processing units, CPUs. What is it that those processors are actually doing? Do they understand sound? What is it that they do to translate a press of the keyboard into sound out of the speakers? Well, this requires us to understand a little bit about what the computer treats as information or data. And the fundamental idea there is that a computer only operates on electrical signals. Now, those electrical signals are not waves. They are actually pulses of electrical energy that either can be read as off or on, meaning there is no electrical charge or there is an electrical charge. So you can imagine, you've seen perhaps in person or in a movie, the heart rate monitors that bleep when the heart beats. This, as a model, can help us understand the binary computer language, which is the way that information is encoded inside a computer. Every time we see a little bloop, we can consider that a 1, meaning on. There is a signal. When there isn't electrical energy, we consider that an off or a 0. Now, the clever thing that engineers have designed is how can we encode any type of information that a computer works with in 1s or 0s in certain orders. This is the magic of a computer, which is if we can create components, all of whom know how to deal with 1s and 0s, we can use a central processing unit to coordinate how those components talk to one another. What do the 1s and 0s actually mean? For example, if we wanted to print the name of the song we want to play, we would have to figure out a way to represent the name of that song in binary, because a computer only knows about how to move and store and display digital information, binary information. Let's use as an example letters that we could then put together to make a name of a song. So for example, my nickname is Zan, X-A-N. If I'm storing my nickname in the computer doesn't know what an X is. An X isn't a concept that a computer can understand, but rather engineers have created a correspondence between the English letter X and a sequence of ones and zeros, which the computer can understand. It can store ones and zeros on a hard drive or flash drive. It can process it and convert it into a set of pixels that make an X shape that's displayed on the screen. Now, I used a binary converter application on a computer to look up how is an X represented in binary. And I'm going to peek over here. And the X is represented by a string of 8 digits, 0, 1, followed by 4 ones and 3 zeros. 1, 2, 3, 4, 1, 2, 3. That is 8, we'd say, bits, meaning 8 slots that could be either 1 or 0. The computer has stored information about how the zeros and ones are corresponding to an X on the screen. An A, for example, is 0, 1, 1, 0, 0, 0, 1. 0, 1, 1, 0, 0, 0, 1. 1, 2, 3, 4, 5, 6, 7, 8. There are 4 zeros here. So we have X, we have A, and then an N is 0, 1, 1, 0, 1, 1, 1, 0. 0, 1, 1, 0, 1, 1, 1, 0. So inside the computer, the central processing unit only processes the binary version of XAN. With that as a foundation, let's think about what components need to happen. What components need to be present. So a keyboard, we would say, is a way to get user information or user desires into the computer. So we call this an input component. Just like the wheels in our steering system we can think of as an output component, the speakers in our computer example is an output component. Notice we have no lines connecting these, which we'll do in just a moment. Is a keyboard connected directly to the central processing unit, the unit that is coordinating among these components? No. The keyboard has a wire that's plugged into a port on the computer. Ports we could think of as receptacles for connecting the inside components to the outside components. An electrical signal from the key press on the keyboard passes through a wire. In other words, this is a flow of digital data, which means a series or a sequence of ones and zeros. You can think about those ones and zeros as electrical impulses traveling down a wire, just like that heart rate with the little blips. That signal moves into the port, and there is a component that we're going to represent by a long rectangle that's called the bus, or the communication bus. Communication bus is a component that coordinates movement of information between the inner bits of how the computer functions. Now, we're thinking about how to play a song. Does the CPU know how to play a song? No. The CPU is going to coordinate between some sort of permanent storage device and an output component, an audio card, that is capable of converting ones and zeros, binary data, into electrical signals that move the magnet on the speaker. That's actually something called a digital to analog conversion process. which means when the signal comes out of our audio card into the speakers, we have a left and a right, and this is analog sound, meaning these are not ones and zeros. The audio card is translating the ones and zeros that move through our computer components into audio sound. So if we ask the keyboard to move the selector on the screen up and down to select a song, that signal goes into the communication bus. The communication bus says, okay, the CPU has to do some processing of figuring out where in the computer is that particular song stored in the hard drive. So hard drive is a permanent data storage device that can store lots and lots of ones and zeros and those ones and zeros are stored in a location that the CPU and the hard drive together know how to access. So we actually have a flow to and from the hard drive. We can save information on the hard drive and then we can extract it. The CPU is coordinating this. Now, hard drives are not very fast at information retrieval. Now, when I say not very fast, I mean it might take 1/100th of a second to get a series of ones and zeros out of the hard drive. The processor can process information much faster. So there's an important component of a computer called RAM, Random Access Memory, which is contained on the motherboard that serves as a temporary storage device for information that the CPU is working with moment to moment. So in this case, without getting into the weeds too much, the process of playing a song will involve retrieving a long sequence of ones and zeros that represent each of the particular sound, little bits of sound, microseconds of sound on the song, and transfers that into the RAM for temporary storage as it is processed with the CPU. When the CPU is ready and has done enough processing to give signals to the audio card that the audio card knows how to convert into analog sound, it moves down the communication bus and into the audio card itself, which then does all of the work. Now, I didn't label any of these arrows yet. In these cases, these are all ones and zeros, or digital signals. We'd say this is the flow of data. As we'd expect, these are electrical components, and they require electricity. So to round out our diagram, we need to include a component which is the power supply. That supplies electricity to each of the components. So in other words, we have two types of flows in our diagram so far. We have the movement of digital data and we have the movement of electricity. Out of the audio card, we have the movement of analog sound, which means it's not encoded in ones and zeros. This is a simple example of how a computer's components are related in order to make simple tasks occur and more complicated tasks. Let's take a peek at what those components look like in the computer itself. So here's our IBM component. Let's take a peek inside. Now, I like to use older hardware like this. Ouch! Whew. I like to use older components like this because things are bigger and it's easier for us to see what each of the components look like and what they do. So what we're seeing here are printed circuit boards, which are green plastic. On each of these circuit boards, we have tiny little wires that transmit signals. We can see that this motherboard is the coordination hub for all of the information that flows through the computer. And then additional components are plugged into that motherboard for movement between one another. This component, the communication bus, is actually embedded inside of this blue circuit board. It has lots of very tiny wires there. A couple of things to note. We talked about the RAM, which is our temporary storage device. RAM exists on what are called DIMMs, or cards that systematically can store data for very quick retrieval. I'm going to take out a RAM card. RAM looks like this. RAM is often a factor of influences how fast a computer can go, because if the RAM can't keep up with the processor, we have to wait for it, and that causes things to slow down. So when people say I want a faster computer, they're usually talking about increasing the speed of the processor and increasing the amount of RAM, meaning the amount of temporary storage that you can have in memory at any particular time. So we think about RAM as the short-term memory of a computer, and then the hard drive as the long-term storage in the computer. One of the trade-offs with RAM is that it is volatile storage, which means it is unable to maintain its information when power is no longer supplied to the computer itself. The hard drive, which I can see over here, however, is considered permanent or non-volatile storage because it can maintain its information even when the computer is powered off. So here is our, let's get that locked. This is our hard drive. You can see that in this component we actually have two flows, just like I drew up here on this diagram, which is this big ribbon cable has lots of little wires. This is what transmits the data, the ones and zeros, from the motherboard bus up to the hard drive for sending and retrieving data. These bigger wires, you can see, come back and attach to our power supply, which allows the hard drive to spin and provides enough electricity to store and retrieve data. So the computer process involves, or the computer building process involves connecting these components together and making sure that the connectors are compatible, and also to make sure that the signals that they're sending to one another, they're capable of understanding. Now, you're probably thinking about, well, where's the CPU? We've got the RAM here. Where's the component that actually does the crunching, that knows how to do the mathematical operations on the ones and zeros to convert the ones and zeros of the song into analog signal? That is actually located underneath this aluminum heatsink and a fan. The reason that we have to have those is because the process of using electrical signals to do math creates lots of heat. Heat is the enemy of electronic components. As the temperature of an electronic component goes up, the speed or the resistance increases, which means those ones and zeros move slower. The transistors, the miniature components that do those processes, slow down. Now I'll actually show you an example of a processor itself that would be buried underneath the heatsink and the fan. You can see this is the processor itself. It contains about 1 billion, yes, 1 billion transistors that are the microprocessing components that make a computer tick. So our processor lives underneath the heatsink, and the fan moves heat energy away from the processor and into the air to keep it cool. Those are our core components of the computer that I want you to be familiar with. So on your note cards, we should have central processing unit, RAM, hard drive, communication bus, some sort of user input device. This could, of course, also involve things like a mouse with 2 buttons. It could involve cameras, all of which have ports that connect up to the communication bus. So we could have a camera device that is communicating to the computer. Each of these ports has names. For example, we're familiar with Universal Serial Bus, USB, which is a very common way to transmit information between input and output components and the way that the computer, into the internal bits of the computer. That gives us an overview of the core components of a computer. Your job is to take this understanding, translate it into note cards, each of which contains the name of the component and then a definition in your own words of what that component does. So let's just run one final example of what you might put on your note cards. A note card for the hard drive might look something like this. Hard drive. We could label it, if I go on the Wikipedia site and review what a hard drive does, I need to convert that information from the Wikipedia page into my own words, my own personal definition of what role does the hard drive play in the computer. And if I look it up, I would see that the hard drive provides permanent storage of digital data that is then retrieved and operated upon by the central processing unit, distributed out to the various components. So the key words here are permanent, digital, data storage, and what's it connected to? It is connected to the motherboard bus, and that's a pretty sufficient note card. And we can see that if we have our other components on note cards, we can then arrange them. You could put these on a large sheet of paper, tape together a couple of 8.5 by 11 sheets of paper so that you can actually set them together and say, okay, hard drive is going to go into our communication bus. We could draw that to look more like, or I guess if we have it on a note card, communication bus. And this is a transfer of digital data between internal components. Now you'll notice I'm not telling you exactly what every component does. Part of the online learning process is learning to read and digest technical information about how the computer works. I'm giving you enough of an overview that you should be able to make sense of the data that you're reading or the information that you're reading online. So with that, that is going to conclude our week 1, which is configuring the components of a computer, thinking about how they're related, and then next week, after you've uploaded your diagrams of both your computer and non-computer system, I'll do some review and we'll look at some final diagrams of how a computer is put together, and we'll layer in the operating system and build up from there for the remainder of the course. All right, have a good week. We'll see you soon.